Hi everyone, and welcome to week 4 of 10 in Math 90. This week I will be helping you through the material of fractions. And so let's take a look at what we'll be covering this week. So we're going to visualize fractions, we're going to multiply and divide fractions, we're going to multiply and divide mixed numbers and complex fractions, we're going to add and subtract fractions. We do addition and subtraction after multiplication and division because it's actually more complicated to add and subtract fractions than it is to multiply or divide them. And then we're going to do the same with mixed numbers, and then we'll solve some equations with fractions. Okay, please remember that for all of these problems we can use our graphing calculator, and that will be just fine. You can use your graphing calculator on all your homeworks, on your quiz, on the final exam. All right, and I'll show you a little bit more detail about the TI-84 and how to use that during this webinar. All right, so different representations of fractions. We can have a mixed number, we can have a proper fraction, and we can have an improper fraction. So a mixed number is something that results from having a whole number and then a fraction. So something like 3 1/2. That would be a mixed number. Now, if we were to write this as a proper fraction, we couldn't. But a proper fraction is a fraction that's somewhere between 0 and 1, where the numerator is smaller than the denominator. So something like 1/4 would be a proper fraction. But if I were to convert the mixed number 3 1/2 into a fraction and not a mixed number, 3 times 2 is 6 plus 1 is 7. So this would be 7/2. And this is considered an improper fraction because it has a numerator that's larger than the denominator. Now, I would prefer to see your answers as an improper fraction unless they specify something else. But just because it says improper in the name doesn't mean it's the wrong thing to do. It's actually what's preferred most of the time. And if you're going to do operations with fractions, you're going to be working with improper fractions more than you're not. Okay? All right, let's move on to the next thing. So we want to be able to convert between forms. So we're going to convert 93/9 to a mixed number. So 93/9, a fraction and division are the same thing. So what this is really saying is 93 divided by 9. So 93 divided by 9 gives me 10 and a little bit. It gives me a decimal, so 10.33333. All right, so I know that the whole number in this mixed number is going to be 10. 10 times 9 is 90, with 3 left over. So I'm left with 3/9 left over. We always carry the denominator with us as the denominator of the fraction part of the mixed number. What we want to make sure is happening is that we reduce that fraction. So 3/9 can be written as 1/3. So this is really 10 and 1/3. Now I did that by hand, but what you can do is you can use your calculator to help you do this. And I'll show you how to do that. So I'm going to share a different screen. Bear with me for 1 second. So here we have a calculator. This is our TI calculator. And what we can do here is, if you have the newest version, you can hit alpha, and then the button right next to it will give you a fraction. And so we had 93 divided by 9. Oops. I don't need to put the division because 93 divided by 9. If we hit enter, it's going to give me 31/3. Okay. Now, that's a fraction. Okay, it's still an improper fraction, but at least it's reduced. So now to get it to give me a mixed number, we can go into here And the third option is going to convert from a regular numerator denominator to a unit and then a numerator denominator. So the third option, again, let me show you how I got here. So I hit alpha y equals, and it brought me to this menu. I'm going to choose option 3, and it's going to take the previous answer and convert it into a mixed number, which gives me 10 1/3, which is exactly what we had as our answer. So let me show you that again. We can put in our improper fraction by hitting alpha y equals, so the first choice here gives me the fraction, or we can hit alpha, the button right next to the fraction. I'm going to clear that out. So either one of those will work. You can put in 93 over 9, and then you can convert that. Alpha y equals number 3 will convert that to a mixed number for you, 10 1/3. All right, let's go back to our PowerPoint here, our presentation. Here we go. So now we want to do the opposite here. We want to convert 3 2/7 to be an improper fraction. Okay, so what I can do here is we're multiplying. I want to know how many sevenths 3 is. So 3 times 7 gives me 21. So that's 21 sevenths. And then there's another 2 sevenths. And so that gives me 23 sevenths. So 23 sevenths. So essentially what I'm doing is I'm multiplying here, and then the result, I'm going to add this number 2. And I keep the denominator of 7, so I get 23 sevenths. Again, I can do this in the calculator, and I will share that with you. So our idea here, let me clear the screen. We started with a mixed number, so I'm going to hit alpha F1. Option 2 lets me put in 3 2/7. And what I can do is I can hit enter, and it will just change that to an improper fraction for me. 23 sevenths. So you have the calculator. I'd like you to take advantage of that calculator. So please make sure that on your quizzes and your homework, do it on your homework first so that you can practice, and then on your quizzes and the final exam, have that calculator. Make sure you know how to use it to your advantage. All right, so that's visualizing fractions. Another part of the visualization that throws people off on the homework in Newton is there's a little interface where you have to drag to change the number of spaces between whole numbers, and the number of spaces should be equal to the denominator of your fraction. There's a video that I have for that, and it's in that schedule, the suggested schedule that was posted. So you can use that to help you, or find it on My Nightingale. All right, so next up is multiplying and dividing fractions. So multiplying fractions is the simplest operation, because all we have to do is we have to multiply across. So we multiply the numerators. 2 times 4 is 8. We multiply the denominators. 9 times 5 is 45. And so there we have it. Now, if I could reduce this, I would, but I don't think 8 has any factors that are in common with 45. I can also use my calculator and use the fraction to write it exactly the way that I see it. So it'd be like 2/9 as a fraction times, and then make another fraction and do 4/5, and it will give you the answer as a fraction in reduced form, and it's spitting out 8 over 45 for me, so that's great. Remember, numbers can be negative, and so I have one overall negative sign, so that means the overall is going to be negative because I count up the number of negative signs. If it's an odd number, we have 1 here, so that's odd. The whole answer is going to be negative. If I had an even number of negative signs, then my final answer would be positive. So then we have to multiply across. We have 2 times 8 gives me 16. We have 7 times 11 gives me 77. And so we have negative 16 over 77. And again, there's no common factors between the numerator and denominator, so I can't reduce this at all. All right, so that's multiplying fractions. Now let's get into dividing fractions. When we divide fractions, we actually rewrite the problem as multiplication, and then we don't have a new skill. So to rewrite this first problem as a multiplication problem, we're going to take the second number. So we're going to take this second fraction, and we're going to flip it. We're going to find the reciprocal of it. Dividing by 4/5 is the same thing as multiplying by 5/4. So this is equal to 2/9. Notice the 2/9 stays 2/9 times 5 over 4. So dividing by 4/5 is the same thing as multiplying by 5/4. And now I can go ahead and multiply across like we did before, and that gives me 10 over 36. Now both of these numbers are even, so I know that I can reduce this. So I'm going to divide by 2, and that gives me 5 over 18. And now I know I'm reduced because 5 doesn't go into 18 evenly. And so that's my final answer. So same thing here. We have negative 2/7, but I'm going to be multiplying that by 11 over 8. Now on the last problem, I simplified after the fact. I multiplied and then I simplified. Here I'm going to simplify beforehand, which is another option. I see that 2 and 8 are both even, so 2 goes into 8 4 times. So this becomes a 1 in the numerator, and the 8 becomes a 4 in the denominator. Now I can multiply across. 1 times 11 is 11. 7 times 4 is 28. And I have one negative sign, so I have an overall negative answer. Again, if this is too much, you have your calculator. You can just plug it in exactly the way it looks, and your calculator will not only give you the answer as a fraction, but it will give you the most reduced fraction, and so you don't have to worry about that. So that's multiplying and dividing fractions. So now we're going to get into multiplying and dividing mixed numbers and complex fractions. So if I want to multiply mixed numbers, I need to make sure that I'm converting them into improper fractions first. So that's my first thing, is to convert these into mixed numbers. Because when we have a mixed number, what we're really saying, what this problem is really saying, is 4 plus 3/7 times 2 plus 2/3. So I can't just multiply the whole numbers because there's addition happening in parentheses. So I have to take care of the addition first. And so that's where converting these into improper fractions comes in. So 4 times 7 is 28, plus 3 is 31 sevenths. And then 2 times 3 is 6, plus 2 is 8, times 8 thirds. And now it's just a matter of multiplying across. Okay, so 31 times 8, I'm definitely doing that in my calculator, gives me 248. And then 7 times 3 is 21. So 248 divided by 21, turn that into a fraction. It's just 248 over 21. If we are given an answer as a mixed number, they might ask for your answer as a mixed number. So I'm going to hit that alpha y equals, and I'm going to convert this into a mixed number, and that gives me 11 and 17/21. So depending on how they ask for the answer, it's either going to be the improper fraction reduced as much as it can be, or this mixed number. And so just make sure you're paying attention to which one they're asking for. All right, so this next one, we're dividing. So first we're going to convert into improper fractions. 5 times 11 is 55, plus 6 is 61/11, divided by, we have a negative. So 1 times 6 is 6, plus 5 is 11/6. Okay? But we're dividing. So first, I convert to improper fractions. Next, I'm going to convert this into a multiplication problem. So we have 61/11 times negative 6/11 multiplied by the reciprocal. And now I can multiply across. I'm going to have an overall negative answer because I have one negative sign. 6 times 61 is 366. 11 times 11 is 121. So I'm putting this in my calculator because I want it to give me the most reduced fraction. So that is it right there. And then I'm going to convert it into a mixed number. And so that gives me -3 and 3/121. So again, depending on how the problem tells you to give your answer, it's going to be either of these results. All right. Let's do some evaluating using the order of operations. So remember, when we talked about the order of operations, we talked about how a long division sign is considered, or a fraction sign is considered, a grouping symbol. So I actually have to do what's in the numerator and what's in the denominator first before I do this division. So I'm going to take care of the numerator. First, I use the exponents. So I'm going to raise 5 to the second power, that's 25, minus 3 to the second power, that's 9. And then 3 minus 5 in the denominator is -2. 25 minus 9 is 16. So we have 16 divided by -2, and that's actually -8. And so my final answer is -8 here. Just follow the order of operations. When it says to evaluate, that means you should end up with one number in the end. Now that could be a mixed number or an improper fraction, but you're looking for a single number at the end of the problem. Okay? So you shouldn't still have division signs. If you can reduce the fraction, like here we had 16 over -2, that can be reduced to -8. You're going to want to do that. Let's try another one. Again, the numerator and denominator, because we have this big division sign, this is like one giant grouping symbol, so we have to do everything in the numerator and everything in the denominator first. So I'm going to start in the numerator. 7 times, I got to do what's in parentheses, so we have 6, and we have 2 times 7. In the denominator, we have 5 times 7 minus 2 times 13 minus 6 is also 7. Now it might be very tempting for you to want to cancel some of these 7s because there's one in the numerator, one in the denominator. You cannot do that because, again, the order of operations here is saying take care of what's in the numerator first and what's in the denominator, then we can do some division. But right now we can't do the division, so we can't cancel 7s out until I subtract. But I can't subtract here until I do the multiplication, because the order of operations inside the parentheses follows the regular order of operations. So 7 times 6 is 42 minus 14. And then we have 35 minus 14. Again, you cannot cancel the 14s here, so please don't try to do that. So now I have 42 minus 14, which is 28. And I have 35 minus 14, which is 21. Now both of these are divisible by 7. So this is 4/3. Now, I could also have put this in the calculator the way that it was written originally, and it will spit out the same answer. Okay. All right, let's move on. So here we have we have a complex fraction. So this is like the division sign. This is like our fraction. We have a numerator that is a fraction. We have a denominator that's a fraction. So that's called a complex fraction. But remember, this purple line that I just drew in, that's a division sign. That's really saying divide these two things. So we can rewrite this as 2/5 divided by 3/7, which we would then rewrite as a multiplication problem. Multiply by the reciprocal 7/3. Now we can multiply across 14 over 15, and we're done. That's it. So sometimes things look really complicated or complex. We do a couple of things to it that we know are true. Like a fraction is a form of division. And so then we just rewrite it in a way that looks familiar to us. And then we can evaluate it that way. All right, let's do one more complex fraction. Now this one has variables in it, so the calculator wouldn't help you to find the final answer here. You would have to know how to do some of this stuff. But it's the same process. We have this division sign in the middle here. That's our division. And so writing x over 7 divided by xy over 9 is the same thing as writing x over 7 times 9 over xy. Dividing by a fraction is the same as multiplying by the reciprocal. And now we just multiply across. So we have 9x in the numerator. We have 7xy in the denominator. Now here I have x divided by x. And so I can absolutely cancel out an x divided by x. Any number divided by itself is going to give me 1. And so I'm left with 9 over 7y as my final answer. All right, we're doing good here. We are halfway through our objectives for today. So now we're going to get into adding and subtracting fractions, which is actually more complicated. So in previous weeks, we talked about combining like terms. And so whenever we're adding or subtracting, we need to have like things. And I use the analogy of nickels and dimes. When we talk about nickels and we talk about dimes, we can't combine them or loop them into a single nickel-dime sentence because that's not a word, that's not a thing. And so we have to keep them separate. So the same is true with fractions. We can't add fractions together unless they're like fractions or they have the same denominator. Okay? So here we have two examples where we're adding and subtracting, but we already have fifths and ninths. And that's good. If I have 3/5 and I'm adding 2/5 to it, those are like things. Those are like terms, and so I can add them together. 3/5 and 2/5 gives me 5/5, which is known as 1. So again, your calculator will do this work for you as long as you know how to put fractions into your calculator. Check announcements for how to do that. The final answer here being 1. So now for the subtraction problem, I have 5 of these ninths, and I'm subtracting 7 of these same ninths from it. So I have 5 of something, and I'm subtracting 7 from that. I'm taking away 7. So that leaves me with -2. -2 what? Well, -2 ninths. So that's the way that we can think of this. Like if we had a variable like 5x, that means I have 5 x's, minus 7 x's would give me -2 x's. And so it's the same thing with fractions. We need to make sure that we are working with like terms, like bases, or else this does not work out. Okay, so let's do this again, but when we do not have common denominators is what it's called. I keep calling it like bases, but basically we're talking about having like terms. So 7, and I have 3 of these sevenths, and then I have 2 of these thirds. But those aren't the same thing. So I need a common denominator. And the way that we do that is we come up with a common denominator by finding the least common multiple. So least common multiple between 7 and 3. So 7, if I count by 7s, I get 7. 14, 21, 28, etc. If I count by 3s, I have 3, 6, 9, 12, 15, 18, 21, etc. Now, the first number I come across that's in common, that is our least common multiple. And so in this case, our common denominator. We want our least common denominator, and so that's 21. Also, if you multiply the two denominators together, that will give you a common denominator. It might not be the least common denominator, but it will be a common denominator that will work. So here we have 21 as our common denominator. To get from 7 to 21, I have to multiply by 3. So that means I also have to multiply 3 by 3, and that gives me 9. So 3/7 can be written as 9 over 21. We also have to get from 3 to 21, and I do that by multiplying by 7, which means I have to take the 2 and multiply it by 7 as well, and that gives me 14. So 2/3 and 14 over 21 are the same thing. So now I have two fractions with the common denominators, and I can add. I have 9 of these 21s, 21sts. I have 14 of these 21sts, and I'm going to add them together. 9 plus 14 over 21. 9 plus 14 is 23, obviously. And so my final answer is 23 over 21. So I'm going to do the same thing with subtraction. I want my least common multiple between 6 and 4. So if I count by 6s, 6, 12, 18, 24. If I count by 4s, I get 4, 8, 12, 16. Oh, so 12 is my least common multiple, which makes it my least common denominator. So to get from 6 to 12, I multiply by 2. So I need to multiply 5 by 2 to get 10. And to get from 4 to 12, I have to multiply by 3. So I'm going to multiply 3 by 3 to give me 9. So 10 twelfths would reduce to 5 sixths, so they're the same number. 9 twelfths would reduce to 3 fourths, so those are the same number. And I don't know why I put an addition sign here, because we are subtracting. 10 minus 9 is 1, so we end up with 1/12 as my final answer. Again, you can just use your calculator. Alpha, the button right next to alpha, gives me, so 5/6 minus alpha 3 divided by 4. That gives me 1/12. And it just did that for me. I didn't have to do any work to reduce or anything. So use your calculator when you can. So that's adding and subtracting fractions. Now we're going to go ahead and add and subtract mixed numbers. And as you would expect, you would do this by, you could convert these into improper fractions and then do exactly what we just did here. But what we can actually do as well is think of this as 3 plus 2/3 plus 2 plus 4/5. So mixed numbers, the reason I'm not a huge fan of mixed numbers is it's inconsistent with what we think about when we have two numbers just sitting right next to each other without a sign. So typically, if we have two numbers right next to each other with no symbols, it means multiply. So if we have 2x, it means 2 times x. But here is the only place in math where you have two things right next to each other and it means to add. We have 3 and 2/3, so 3 plus 2/3. Because this is all addition, and addition is commutative, meaning it doesn't matter which order you write it in, I can think of this as 3 plus 2 plus 2/3 plus 4/5. And so I can actually just add the 3 and the 2 together, and that's going to give me 5. But now I have to add the 2/3 and the 4/5. So I need a common denominator, and the least common denominator is going to be 15 here. So to get from 3 to 15, I multiplied by 5. So I need to multiply 2 by 15. Sorry, not 2 by 15, 2 by 5, and that's going to give me 10. To get from 5 to 15, I had to multiply by 3. So I'm going to multiply 4 by 3. That's going to give me 12. And so that's 27. I have 5. Then I have, 22 fifteenths. But I can't write this as a mixed number because the fraction has to be a proper fraction. It can't be improper. So 15 goes into 22 once. So that's going to give me a 1. And I'll be left with 7/15 left over. So overall, this is 6 7/15. Now, I also have the option of using my calculator, which, why not? Alpha y equals, put in a mixed number, 3 2/3 plus alpha y equals, number 2 gives me the mixed number again, 2, 4, 5. So I'm just going to hit enter, and it gives me an improper fraction. I don't want the improper fraction, so I'm going to hit alpha y equals 3, and it converts to 6 7/15 for me, which is great. All right. So this next problem, I'm actually, write it down, and we're just going to do this one on the calculator. I'm just going to show you on the calculator how to do this, and that'll be how we complete this problem. So let me share my calculator here. Still have stuff from last time, so I'm just going to clear that out. So we had the problem, so I'm going to hit alpha y equals option 2. So I have 4 5/6 minus alpha y equals 2 7 and 7/8. And then I hit enter. It gives me an improper fraction, negative 73 over 24. I want a mixed number, so I'm going to hit alpha y equals number 3, and it converts to an answer of negative 3 and 1/24. So if they want the improper fraction, I'm also going to write that down just so that I have it. But typically, if they give you a problem with mixed numbers, then the answer is going to be mixed numbers as well. All right, let's go back to our presentation. So that was the answer, and we just did that right on the calculator to make it easier. Okay, so now we've added and subtracted mixed numbers. We're moving on to solving equations with fractions. So, I'm going to start with, we have some number, minus 5/6 gives me negative 4/3. So to undo subtraction to get x by itself, I'm going to reverse engineer this. So I'm going to first add 5/6 to both sides. Now, x minus 5/6 plus 5/6 is just x. So that's how I isolate my variable, is by undoing what's happening to the variable. And now I need to do negative 4/3 plus 5/6. Well, negative 4/3 could be written as negative 8 over 6. Multiply by 2, multiply by 2. Plus 5/6. So I have negative 8 of these sixths, and then I'm adding 5 of these sixths. So that leaves me with negative 3 over 6, also known as negative 1/2. I could also just take my calculator and put in negative 4/3 plus 5 over 6, and it also gives me negative 1/2. So x is equal to negative 1/2. I like the calculator as a check. And that's how we do it. So it's the same idea. If we had x minus 5 equals negative 4, we would add 5 to both sides. It's the same process. It's the same ideas. We're just using fractions instead. So now we have negative 12x equals 13. Right now, x is being multiplied by negative 12. So to undo that, we're going to divide by negative 12. The negative 12s cancel. I just am left with an x. So I have a 1 times x, which is x. And then on the right side, I have 13 divided by negative 12. So that's negative 13 over 12. If they wanted a mixed number, I would rewrite this as negative 1 and 1/12. All right, couple more. So here I have x is being multiplied by negative 5/7. So to undo multiplication, what I want to do is divide by negative 5/7, or divide by negative 5/7. Negative 5/7 divided by itself cancels, and so I'm just left with x on the left side of this equation. On the right side, I'm going to rewrite this as a multiplication. If I'm dividing 45 by negative 5/7, it's the same thing as multiplying by negative 7 over 5. Now, we haven't really multiplied a whole number by a fraction today. So if we think of 45 as 45 over 1, we can just multiply across. Multiply numerators So 45 times -7 gives me -315 divided by 5. And that's going to give me exactly -63. I also could have reduced this ahead of time. 45 divided by 5 is 9. 9 times -7 gives me -63. So x is equal to -63. We can plug that back into the original equation to check our answer, but this is correct. All right, last one. X divided by 7 is equal to -11. So again, even the way I said this, you might look at this and see a fraction. I look at it and I see a division problem. X is being divided by 7. So I'm going to undo that by multiplying both sides by 7. 7 divided by 7. That just gives me x. -11 times 7 is -77. And that is my final answer. All right, so I do realize that fractions can be a sticking point for a lot of people. I get this. I'm not trying to discount it in any way. Make sure you learn how to use your calculator so that your calculator can do a lot of the heavy lifting for you. And please try to realize that fractions are not any more complicated than anything else we've been doing. You just have to be careful with the way that you write out your problem. So writing things neatly will keep things organized for you. And the more organized your work is, the easier it is to stay on top of it and to keep things clear in your mind. But again, the calculator is there to help you. So please learn how to use it. If you're not using a TI-84 Plus, and you have the TI-30X2S, there are also resources available for that as well in announcements in your course. Don't forget about your other resources. You have the Math Lab, which has tons of videos for you. You have your instructors that are just dying to help you, and that's through the foundational chat, the Math Lab chat. You've got drop-in study halls through the Math Lab and through Foundational. You've got one-on-ones that you can book with your foundational instructors or other coaches in Foundational. Please take advantage of those resources. All right. Any questions? All right, so the videos that I mentioned, they will be in announcements in the course or available on My Nightingale. All right, well, I appreciate you coming out, and I hope you have a great week 4 in this course. Thank you, and see you in the next one.